maybe you can plot the P, okay, orange, P versus this omega. Can you see my screen? Because this time from here, the solution here is correct. And then you just plug in the values and then you can find the lambda, not the lambda and the phi. And after you find the lambda and phi, you have no problem to find this. Okay, you have no problem to find this. So because of this lambda 4, lambda 2, and so on, you expect many values. You expect a certain region of this, and then you for one value of this, when you use the root finding, for example, for a certain set of ABC, you can find one set of ABC, you can find two values, and that is the same as when you look at this square, this 2 power of 4, for one value of W, you will expect maybe you can find one up to 4 values of this lambda. Okay, so once you find the lambda, then you can find the corresponding phi. So you can find the P for the particular lambda and the phi. And the root finding, usually you can find a few different value of x. So for different values of this lambda, you can find this phi correspondingly. So that's why maybe you can find up to 4. Okay, let me insert. Okay, so maybe you can find okay, when you do like, because it is the same same omega, so that's why you put it here. So the same here, actually you for example here you can find the two values. For one set of this ABC, you can find two values of x. And then the control parameter of this equation is all this constant. Okay, all this constant. So all this constant, you make it fixed. Also the z here, you make it fixed. The thing that you change is the omega. So for each omega, you expect maybe 1 to 4 solution. So after you solve this, then you can find your P, and after this you plot the P versus omega. You hear what I say? So you plot the P versus omega, also a kind of showing the bistability, because the graph here, the author fixed only one omega. You know, when you want to plot the graph, you can fix the frequency. Okay, fix the frequency and change the intensity. The S here carry the intensity. Okay, and what I said just now is you fix the intensity. Okay, you fix the intensity and then you change to omega. You change the frequency. Do you grab what I said? So this is a suggestion, but if you manage to work out the S from the E cross B, remember you have if you want to work out the S here, you must use the Maxwell equation. Last time I said already is I omega B equals to del square E. Okay, then you can find the S. You find the B and then you cross the E, then you can find your S. And but that process is a bit tedious. I think it's quite difficult because I try to find the internet. The work there is done by a PhD student. So I think maybe is quite difficult for you. So, but anyway, we have already reached here. What you need to do is put into the numerical solution. You change the frequency, and then you find the multiple values of this because of the fourth order equation. Okay, you find 4 values of gamma lambda, each lambda will give you the corresponding phi. Then you can find the corresponding p. Then you can plot the p versus omega. Do you get what I'm saying? Because if you plot the p versus omega, then you have no more mathematics already. You simply solve this by the software. Okay, the software that you use is the root finding. Root finding. Let me see whether from internet, whether you can find anything about root finding or not. Okay, I want YouTube. Let me see. YouTube. Okay, we go to root. Root finding. Root finding for Python. You want to switch to Python or still stick to Mathematica? Python. Finding root in Python. Okay, you can see my screen. So if you want to start, then you can see many of these. If you don't want to use Python, you can use MATLAB. But whichever you try to use the free, the Python, is it free? Is the Python free? Okay, so you can see my screen, so you can okay, maybe you can start with the square root. Root finding algorithm, bisection method. Okay, there are many methods, but before you put into the things here, before you put into the equation, I don't know, maybe whether you need to convert to exponent or not, or just leave it like this. Maybe you try both. Let me stay enough time. 3:30 already. Newton's method. Square root. See how this author is doing. Win, show me where to go.
Okay, I want to do a little tutorial on how to use Python to do root finding. For example, how to solve equations numerically with this method, equations that can't be solved analytically, solve more complex problems. So I'll do a few of these examples in Python. I'll show you how to program it, and all will be clear. So, to start out, let's do an easy example. Let's say you have the following equation: x squared plus 3x equals e to the square root of x. The problem is you want to solve for x, but this is non-linear. Let's say non-linear, and also we need to accordingly we need to solve this numerically. Okay. So what happens is if you look at the left-hand side of this equation, it'll look something, say, like this. So I'll look, this would be the left-hand side. And if you look at the right-hand side of this equation, it's going to probably look something like this. So it'll right-hand side. And what we're looking for is where these two equations equal each other. So you can see that's going to be somewhere here. We're going to find that value.